So that was list comprehensions. Now let's look at generator expressions, which is almost the same idea. So the syntax is the same in that a generator expression consists of a term, a mandatory for clause, and then optional for and ifs clause, as many of those as you want, 0 or more. And there's two differences. The generator expression uses parentheses instead of square brackets. Square brackets mean the list, parentheses means generator. And then the other difference is that the computation doesn't get done all at once. Instead, a generator expression returns a value which is a promise to do the computation later. So if we say g equals this, and then g is this promise, it hasn't done any calculation yet, hasn't calculated any of the terms, and then I can ask, give me the next g. Then it starts doing the calculation, and it keeps on looping through the for clauses, or maybe multiple for clauses, until it finds the first term and returns that. And then if I want, I can again ask for the next g, and it will give me the second one, and so on. Let's look at an example. Here I've defined the function sq for square of x. It takes in the value x, prints out that it's been called, and returns x times x. And here I've defined a generator. From this generator expression, it says return square of x, generate square of x for x in range 10, if x mod 2 equals 0, so that's saying if x is an even number. And notice nothing has happened yet. We didn't get any printing of square was called, so square hasn't been called yet. The generator function is this promise. We can look at it. It says it's a generator object, but no computation has been done yet. Now we can ask for the next g, and now finally square gets called with 0 as an argument, and we return 0 as a result. We can do that again. We get 4, 16, 36, 64. And what do you think is going to happen next? So now we're getting to the end of the loop. Range 10 means 0 through 9, so there are no more. So now when we ask for the next one, Python raises this condition called stop iteration. So it's saying, I've gotten to the end. I have to stop the iteration because there's no more I can give you. I can't give you the next one. Now, this seems a little bit inconvenient because now I've got these errors and my program has to deal with them. But the idea is that you rarely will be calling next directly. Rather, most of the time, you'll be doing this within a for loop. So I can say something like this, where I say for x2 in this expression, do something, and now the protocol for a for loop arranges to call the generator each time, to call the next function, and to deal with the stop iteration function, or the stop iteration exception, and catch that, and so everything works fine. I can also convert the result. So here I've said, I've got a generator expression, and I'm converting that into a list. It does all the work, and then it returns the result as a list. So I never have to deal explicitly with those stop iterations. Now, why do you think I chose a generator expression to implement the zebra puzzle? Do you think I wanted to confuse students, have less indentation so that the code would fit on the page, stop early as soon as I found the first result, or make the code easier to edit to move around the various pieces of the constraints and so on? So check all that apply.